Hi everyone, this is Miss Folly again. So I will continue with the next questions for tutorial 8 nuclear physics. So this is questions number 6. So question number 6 was given you a carbon as your main isotope, which you are given the original's number of activity for this carbon is equal to 0.25 becquerel per gram of carbon, and the half-life of this carbon is 5,730 years. So we can write it over here. The half-life is equal to 5,730 years. And then what else? Right, so there is no other informations other than that. So question A was asked you to find the decay constant for this carbon. Then I will automatically use my half-life definitions, which is ln 2 over with the decay constants. So rearranging this one, I will get lambda is equal to half-life over with the this is supposed to be ln 2 over with the half-life, right? Now substitute everything. So ln 2 over here, and your half-life, which is 5,730 years, you need to convert it through 2 seconds per minute. So substitute change this as usual, then divided to ln 2, you will get your decay constant is supposed to be equal to 3.84 to the power of -2 per second. So this is your decay constant. This is questions number 8. Now we continue with questions B, which you were asked to find how many carbon in 1 gram of carbon. You are given the number of mole, which 12.011 gram, and the relative abundance is 1.3 to the power of -12. If you are familiar with the questions of chemistry to find the number of atom, I think you have no problem to answer this part. So I will start from finding the number of atom first. So I know the number of atom is equal to mass divided by the mass per mole times with the number of Avogadro, which you're supposed to memorize it by now, and times with the abundance number Ra. So substitute everything into this. You will get N is equal to 1 gram over 12.011 gram. This is the mass over mole, times with Avogadro number, which is 6.23 to the power of 23, and times with the abundance number, which is 1.3 to the power of -12. You were given the number over here. Okay, so calculate it. You're supposed to get the number of atoms for this carbon is supposed to be equal to 6.5 to the power of 10 atoms. So this is answer for B. Now we continue with the C, which is by using answer from A to B, you need to verify the activity of this carbon after leaving sample of 0.25 becquerel per gram of carbon. So you're supposed to know what is the relations between the R and also the mass in these questions. Now I will go over here. Suppose from A and B, I supposed to already get the number of decay constant is equal to 3.84 to the power of -12 per second, and then the number of mole or the number of atoms for the carbon is equal to 6.5 to the power of 10 atoms. We just calculate it, and then I need to find the number of becquerels per mass. So this is for C. So R over mass is equal to R over 1 gram, because I was given 1 gram, and then I know R is number of activity, and the relations of R between R with these two is equal to R equal to lambda times beta n divided by 1g. So just substitute lambda with this number and n with this number divided in with 1 gram, you will get your activity, number of activity over 1 gram is equal to 0.25 becquerel per second. So it is proven by these calculations. So that's it for questions number 6.